So the Arduino, the rear-mounted Arduino setup is all wired in. All the units here are installed, wired, wires are groomed as best I can and organized. So Arduino Mega, a shield board that allows me to connect all the additional wires to the right pins, a Seed Studio CAN bus shield here, a 4 electromechanical relay module. Each of them can carry about 10 amps. A Pololu 18V17 H-bridge controller. Blue board hiding behind that is an Type K thermocouple amplifier. So signal in from a Type K thermocouple and communicates via SPI to the Arduino. And then I've got 4 MOSFETs here to drive maybe 5 or 6 amps max via PWM. And then Dillblocks modules, which just do fuses and relays to support these circuits and the, let's say, pumps and motors and whatnot that all of this controls. These guys will handle all of that. And then this guy is a Monarch Instruments, so this is a lab grade signal converter, pulling in the turbo speed sensor signal in and converting that in a very wonderful way to a 0 to 5 volt analog out. Makes it easy for the Arduino to handle and read the turbo speed sensor signal without having to do a super fast processing. So I'm bench testing now all the outputs based on some new programming that I updated to handle all the correct inputs and outputs here. So one thing I'm testing now is the H-bridge controller, and I have a initialization cycle included in the programming that when essentially key on, or when this goes live, it'll cycle the bypass valve, which is an electronic throttle body, and it will check for, it'll cycle open for a period of time, look at the position, record that as a full open position, then it will cycle closed, record that as a full closed position, and check those numbers against some, let's say, acceptable ranges. If all that checks out good, then the bypass valve can function normal, can operate normal, and the e-boosters can operate normal. So what we're looking at here is the voltage from the H-bridge output. So I'm just wired in here to the 2 pins on the connector, and voltmeter connected to those. These are just the general power in, so main power in and ground for the higher current circuits. This is a key on or a trigger, a go live circuit, and this is a dedicated sensor ground. What I've got here, it's just being powered by I think about 13.5 volts from this voltage supply. So when I connect this will be key on, and key on, what you'll see is the voltmeter go positive for a moment. It's about 5 seconds of positive time, then 5 seconds of negative time, which means it's closing the throttle body for 5 seconds, then opening it back up for 5 seconds, and then going back to 0, so going back to a natural state. There's a time delay relay here, this taller of the two, which is a time delay off. And it allows the Arduino and everything to do whatever it needs to do when after key is off. But I'll just go through that cycle again. So as soon as I key on, this will ramp up to 13.48 volts. That's effectively, and then drop down to negative 13.48 volts, and then 0 out again. And I'll do that one more time just to see what, just to ensure that this thing is happening right. So it should go up to 13 volts. Back down to negative 13 volts, and then off. Cool. So that's all working like it should. So time to wire it up in the car and and test everything out.